Okay, this section is 3 topics. The first topic is algebraic. The second topic is what everyone is least favorite, domain and range. And then the third topic is decomposition, which again is algebraic. So, and I don't know if you saw this, I posted yesterday in Google Classroom a link. I really hope you will try it. In fact, I plan to look and see who tries it. In my EDS class, I'm learning that Desmos, the potential that Desmos has, and then GeoGebra. And I've learned that Desmos has a GeoGebra. It's really cool. But this was Desmos that I posted for y'all. I think it's right here. Yep, this. You don't have to have an account. You can sign in with Google. It's free. But this is for you to practice domain and range. And I strongly encourage you to do it because I think it's really going to help. And it should be, I hate to say this, it should be fun. Like, it shouldn't feel like work. You're going to go in. You're going to go in and you're going to read this, and it's going to, like this one says, drag one of the blue points to fix the shaded region so it covers the graph. Notice that it's vertical lines that you're stretching to fit. So like you would pick this one up and you'd slide it to right there. Notice it tells you if you're wrong. Like it gives no feedback if you're wrong, and then all of a sudden if you're right, it'll say awesome. So now you can visualize, okay, that graph runs from -3 to 6. And then you can come over here and pick that. That would be the domain. Then you go next. And it's another one. And another one, but with an arrow. So how do you would just stretch it all the way off the page, okay? Then it goes to range. That's still domain, hold on. Then it goes to range, and it's giving you the visual of trying to read the range correctly. And you drag those. And more with an arrow, with an open circle. What would it look like with 2 arrows? What if it was like this? And then there's a couple more slides where it's testing you. Can you do it now by yourself? Okay, it's not a grade. Necessarily, I might make it a grade, I don't know, but I feel like it would really help some of you with domain and range, okay? So that is linked in Google Classroom under 2.2, and I will link it again under 2.3 today because today has domain and range as well. So it'll be there, and it's totally free, okay? Use it. I'm learning in my EDS class like what Desmos can do, and it is crazy, way more than just a calculator. I could teach a whole lesson through Desmos. So I'm trying to eventually get there, but I'm not there yet. I might find one for this too, I don't know. Okay, so these first 2 slides are the algebra, okay? This should be where it's not that bad. Like I shouldn't lose anybody here. I hope to not lose anybody on the others either. But this is where you're literally following the rule of the function to plug stuff in, and then you're cleaning it up. All right? You will notice the first 2 slides are identical, and that is because I knew you were going to run out of room. So we're going to do A and B on that slide, and then we'll do C and D on the next slide. So let's look at it. Here's the new stuff. Right here is the new expression that you need to memorize what it means to do. It's called function composition. It means instead of plugging a number into a function, you're plugging a function into a function. Y'all with me? You're taking an equation, you're plugging it into another equation, and you're cleaning it up. You're going to write, in this case, you write F first, and you plug G in. Write this down. You're going to write F first, and then you plug G in. Now, that's only because it says F parentheses G. If those were switched, you would write G first, plug F in. Does that make sense? So order matters. Let's make a note. Order matters. We're going to do A and B on this slide. I'm going to copy. A has two parts. It says to find, now this part I can do that. Let's do that. I'll just go over there with the stuff that's high up. We're going to find F of G, and we're going to find G of F. That's A. So the order matters. Whatever is listed first is the function you write first. So I'm going to write function F first. Look at my directions. Here's function F. Here's function G. So I'm going to write function F first. I've got 2x minus 5. Now I'm going to beef out the x, because I'm plugging in function G. This is what we are plugging in. We're plugging in G. So I'm going to write 2 minus 5. And in the beef, I'm going to put G, which is x squared minus 3x plus 8. See that? So it's like you're embedding one within the other. That's it. That is the answer, but we have to clean it up. We're going to distribute the 2. And then what can I do at the end? Combine those like terms. So 2x squared minus 6x plus 11. And that would be the answer. Really crowded, sorry. So that is the function you get when you plug G into F. Now we're going to repeat, but we're going to change the order, which means we're going to write G first, then beat the X out, and then plug F in. So G is x squared minus 3x plus 8. I'm going to beat out the X. So beep squared minus 3 beep plus 8. Now I'm going to change colors. And in here, I'm going to put F. That's the answer, but we've got to clean it up. So you've got to multiply it out, combine like terms. That is a binomial squared, so please don't write 4x squared plus 10, or plus 25, because that's not the answer. There's a whole middle term there. And I've definitely run out of room here, so this might be something where you like go off to the side and you say to yourself, 2x minus 5 times 2x minus 5, what is this? First, outer, inner, last, combine like terms. See that? So that's something I would do off to the side so that I don't, or if you've got plenty of room. I've run out of room. Y'all see how I got that? So now I'm going to put that back in here. I'm going to put it right here. So I have 4x squared minus 20x plus 25. Now what do I do with that negative 3? I'm going to distribute. Minus 6x plus 15. No, that's, yeah, plus 8. Then clean it up. So the 4x squared stays. I got negative 20x minus 6x. Then I've got 25 plus 15 plus 8. That's an 8. It's supposed to be 8. And that would be my answer. And I don't have enough room to circle it without really messing up. Did you get that? Did I have it wrong? So you found F. The way you read this, by the way, let me draw an arrow. That little circle stands for the word of. F of G, not fog or golf. It's F of G. It means compose the function within a function. Now, what do you notice about B? What does B say to find? Did we not just find F of G? And did we not just find G of F, right? So if you have one of those multi-part questions where you just found F of G and G of F and you trust that you did it correctly, then this just means plug 7 into that, and then write what you get, right? I'm going to show you two methods here, because what if you're worried you did this wrong? What if you think there's a chance you've messed this up? If it's a question that relies on this, then you would get it wrong too, right? So let me show you two techniques. I'm going to show you one if you're confident in this, and then I'm going to show you one as a safety net in case you're worried this was wrong to begin with. So I'm going to come over here and write that we're doing part B now, which is F of G of 7 and G of F of 7. Something to note. Like, how do you know when you're finding a number? How do you know when you're finding an expression? Notice this said of x. This means x is in the answer. Notice this says of 7. This means the answer is a number. So notice the difference between the two. Okay? If I say find something of x, it means your answer is a polynomial expression. Or not necessarily polynomial, but an expression, like with x in it. If I say find something of a number, then your answer is a number. Okay? Alright. Two methods for doing the number thing. First method is, if you know you did this right, if you've already found the function that they say to plug it into, then copy the function. So I've already found it, and I'm confident that I found it correctly, and now you just plug 7 in this case. So 2 parentheses 7 squared minus 6 times 7 plus 11. And you would go to your calculator and you would type it in. And confirm, you should get 67. So that's one method. That's where you know you did that right. You just pull it over there. You plug the number in. Okay. I'm going to show you the other method, and I actually think you're going to like it better, even though it's the safety net. If you think you did this wrong, there's nothing wrong with using the other method because it's also faster. You just got to remember that it's a little backwards from what you would think. All right, here you go. Method 2. If it's a function composition of a number, the method is find this. Let me change colors so it stands out. Find this first. Find the innermost one first, which means go to function f, just f, and plug 7 in. So function f. I'm going to say ... here because we're going to try to find it, right? Or I'll just draw a line, this big line there. All right, so function f with 7 plugged in would give me what?
11.
That'd be 2 times 7 minus 5, and you get what? 11.
Okay.
9, right? Everybody get 9? Now you take that answer. It's a domino problem. You take that answer, and now you find the outermost. So you find g of, I'm going to put question mark, of whatever you found from that one. So now I'm going to find g of 9. Plug 9 in here. I think you get 62. So 9 squared minus 3 times 9 plus 8. 81 minus, 27 plus 8? You get 62. Can someone confirm? Yes. So the answer is 62. So let me recap the difference between the two. In this method here, I was simply pulling the equation that I found, and I plugged 7 in. That's only if you feel confident in this. If you think this might have a mistake in it, then method 2, you find the innermost one first, and whatever you get there, you plug it into the outermost one. So it's a domino problem. But it starts with the innermost, then take that, plug it into the outermost, and that's your answer. Okay? And either method works. I have no way of knowing which method you use on the test. So either one works. Okay? Now the next slide is the exact same slide, but now we're going to do C and D. And at this point, you should be able to try it. So try C, where you're writing the function g of 1, you're finding it, not writing it. And D, where you're writing the function f of x. You can compose a function within a function. Well, you write the function first, beep out the x, and then plug the second one in. Give me my water, please. Coach Chris said he needs y'all on the bus at 1:25. I didn't say, like, can I keep them longer, but I was saying that I had a kid making that test up, and he said as long as it's to me at 1:25, so that's what I don't know.
Hey, y'all have fun, please.
So you're going to
I'll be
write
back at 2 in the morning.
G plus
You so
1,
good there.
and whatever you get, you've got to plug it back into G again. Yeah, because it's G of G. So C is going to Part C is going to feel repetitive because you're finding G of 1 and then you're plugging it back into G again. Try. Please. No.
Did you give us the Cassie?
Well, wait, do you Huh?
Did
I
you give us
hope.
the Cassie?
Yes. I hope my yeah, it's plugged in. Okay. You should get for G of 1, you get 26.
Oh, I'm slowly working on this.
Do you plug in there? Did you get 6 for G of 1? Plug it in. Plug it right back into G. Did you get 6 for G of 1? Then you plug that back into G. So now you're finding G of 6. 62? I got 26. Watch your... Did you put -3 times 6? Yeah? Alright, I'll be over there. Hold on. Oh, I wouldn't have done that. You know why? I would go that shorter route. I wouldn't worry about trying to find the function. That's why you're getting bogged down. Don't try to find G of G. Like, don't do that. You don't want to go that route because it's going to be ugly. Yeah.
What do you do for
Now, F of F, because it says of X, you actually do have to find that one. So you're going to write function F, beep out the X, and plug F in, and then clean it up. So that one is a function within a function, and you do have to find it. I would do this method. Not multiply.
I like this.
I would do, I would do the method where you find G of 1, and then whatever you get, you plug it into G. Yeah. Stay with me, try. You can do it. Because, stand by, hold on, let me say this real quick. If your red is not wrong, I'll do light red. Red's not wrong here, but red would be chaotic here. I would not, I don't know why I capitalized F. I would not find G of G and then plug in 1. I would not do that. Because G is a quadratic, and you would be plugging a quadratic within a quadratic. It's going to be chaotic. I would just find, we'll change back to purple. I would find this first, and then whatever you get goes in G. Okay? So you should find G of 1 is 6, and then you plug that back into G. Right?
So if it was like F
E,
G, you would plug
you
F,
do, you get
plug one into
26.
F first, and then whatever you recognize from G, it's just the same.
Is what?
How do you do
No, it's that one.
How do you do the first?
It's the same as the very first one we did, part A. Alright, so here we go.
She said it's like part A.
So G of 1 is 6. Did you get that?
Yes.
Okay. So, this is like I was saying. I'm going to draw an arrow. So now, G of 6 is what? That's the answer. You see how it's a domino? Now, why did I do G twice? Because it said to. How do you know which one to do first? It's always the innermost one. Find G of 1 first. Take that answer. Plug it into the outer one. You get 26. Okay. We good on C? Write the function f. Write just the function for f. What is f, y'all?
F is 2x minus 5.
F is 2x minus 5. If it helps, box it in. Or some people like to get highlighters, and they highlight them so that they don't plug more than they need to in. So you're going to write the function f. Now beat the x out. So write it again, but with a dramatic beep in place of the x.
Sorry.
Then plug f in there. Write f again.
That makes so much sense.
So I'm going to write f first. So make a note. Write this. Then you beat the x out. And you plug in f.
Does that help you?
So f is 2x minus 5. So 2 beep minus 5. And then in place of the beep, I'm going to copy f again.
4x minus 15. Yes.
Yes. That's what you were asking me.
I
The answer. I didn't know you were asking the answer. I'm like, where did she see 4x minus 15?
I thought you thought F was.
I thought you were asking me if the equation for f was 4x. I got you now. Yes, you're correct.
You said that since she didn't understand my question.
Sorry.
Did you get a new pen?
No, it goes to this.
That makes sense.
I do need a new one of those because this little nubbin is like gone. It's gone. Okay. Next slide. It'll be great.
This was so fun.
This looks like a lot of
I
fun.
know we put a lot of
I like that.
Brain break. Y'all, come on.
I'm using 5 star.
I've only been teaching for 27 minutes.
We've done 3 slides. Including the title we've done 3.
The title doesn't count.
You always got a
does
title.
It's a
I've
slide.
done 4 problems. Y'all sure did have to
Yeah,
work
we
hard
have.
on that title slide.
We've done 4 problems, and
We
one
have
of
to
them was
read it.
multi-step. Like it was FMG and GMS.
Why probably should have said goofy?
Use it, make it easier.
If I tell you bandwidth, you guys.
You want an answer? Was that
Good
rhetorical? Were you wanting someone to answer that? All right. No brain break yet. Do this for me. I'll give you a brain break before part B. Your brain break's getting set by a timer that cannot be reset over and over and over again. Hi.
Hi.
Nope, sorry, can't go. Access denied. Keep trying, keep trying. All right. I would love for you right now to find the f of g and g of f. Find that. You're just finding the equation. You're not, oh, Lord help, why is that? Whoa. I have no clue. Yes.
What? Why do you do that?
To make sure it wasn't a screen recorded video. I was writing
All right, find those.
No.
Wait, I don't feel like it's supposed to be.
Miss Holcombe, do you like mango sushi or 1885?
Can you find me a baby tiger or a baby panther cutout and a big tiger cutout? I can't find any
Cutout? Like to print?
that I can put like on the locker.
But it wouldn't be color print. It'd be black and white. Well, with a panther it wouldn't
Yeah, am I supposed to
matter.
Sorry.
I can do a panther.
Doing that for old work when I was like blood on the panther. Like little bitty tiger.
Yeah, but I didn't know if that was right.
Gotcha.
For holiday decoration.
I didn't know it was gonna be that. Yeah, it seemed too easy.
All right, try it. you're finding just the function. Now this one should not require as much work. This should not require as much work because you got one's a radical, one's not. There's not a lot you can do with those, you know?
Riley.
No, she stole it from me. Come here.
I can't open it.
Zero x minus 3, but minus 3 isn't under the radical. I need that.
I sent it to her.
Yeah.
What?
I sent it to her on Tuesday.
I need to remember that. Did you get A? Or did you get this one?
Got good.
Right function F, beep out the X, plug G in. And there's really not much to clean up.
Oh, so it's just the square root of x
So
minus
Square
3.
roots have to be
function
greater
F
than 0.
is the square root of X, right?
Square roots can be negative.
Now beep the X out, so square root beep. Nothing there. Now plug X, G. Plug G in. And that would look like this. Can't do anything. It's done. You're embedding a function within a function.
I don't feel like this is right.
It's going to take practice. It's going to take practice. Now G of F. So what do I write first?
X minus 3.
Okay, and then what do I beep out? Okay, so beep minus 3. And what goes in? Square root X. Can I do anything? No, I'm just going to drop the parentheses. Carefully note that the minus 3 is not under the radical. Okay. So that's all of that.
Do they have the same name?
No.
Okay.
That's where y'all are going to start throwing your shoes at me. How about 5-minute brain break?
No more.
Sorry. Okay. Part B says find the domain of your new functions. Okay. I'm going to try my best to break this down for you step by step, and I need you to know that these domain questions for this unit are these same steps every time. What changes is the function. Was the function linear, quadratic, cubic, a fraction, or an even root, or by chance an even root that's in the denominator of a fraction? That's what changes. But the steps themselves don't change. You with me? So I'm going to lay the steps out, and then you just need to know when you go to practice this, you have to take into consideration, am I dealing with linear, an even root, or a fraction, or a quadratic, or a cubic? I'm trying to think what the other, I think that's all, those are all of our scenarios. Okay, so let's take some notes. The notes are, I'll write it in black for the notes part. The notes are, hold on. We're going to address part B. First, find the, I'm going to do domain of F. Notice I'm doing comma. G first. Meaning the domain of the functions individually, not together. Now this you should already be able to do. And this is what that Desmos link is going to help you practice, okay? So let's look at just function F. Remember, the only thing you have to ask yourself is, do I have a fraction? Do I have an even root? Those are the ones that are tricky. So look at function F. Let's just copy it. Function F is this, right? That's an even root. I'm going to lay it out here for you. All right, I'm going to draw an arrow, meaning like, okay, your mind should say to yourself, even root. Then your mind should say, okay, we can't take the square root of negatives, so what is allowed? The radicand has to stay greater than or equal to 0. That's the same every time. You take the radicand, you set it greater than or equal to 0, and you solve it. Well, in this case, it's just x. So when I go to do that, there's nothing to solve. It ends up looking like this. Okay? Now let's just kind of sketch a visual here. Number line, throw 0 on it, and it's closed and to the right. Which means you can plug any number you want in there as long as it's 0 or higher. All right, now let's do G. G is x minus 3. What type of function is that? It is linear, which means the domain is all real numbers because linear functions have no restrictions. You can plug any number you want into a line. You're going to get an answer. So this is where we have found them individually. You have to do that first. Here's why. Now what we're going to do is find the domain of f of g, and then we're going to find the domain of g of f. Okay?
Since you already found f of g before, can you just use that equation and not have to find which one for each equation?
Ask it again.
Like how we found f line and then we found g line. Since we already found f of g, can you just use the x minus 3 under the line?
Yeah, you're going to. You would need to know f. You would need to know the function in order to answer the domain. Yeah. All right, I'm going to change colors so that now you can see where I am. Oh, y'all just blue. There you go.
Pierce.
No. I was blue.
I got it. It's all right. We're back. All right. And then okay. That's all right. All right. So now we found them individually. Now I'm going to come over here and I'm going to copy the function f of g. This is what it looks like. And I'm going to copy the function. Did they ask for both? Yes. G of f. And this is what it looks like. So all I've done is copy them. What is the domain? You're going to find the domain 4 times. You got to find it with them individually. Now you've got to state it with them composed. What's the domain here? Well, it's an even root. So that means I do what with it? Set it greater than or equal to 0 and solve. And when I do that, I get what? What do I get?
X is greater than or equal.
I get x is greater than or equal to 3. Hold on, I'm running out of room. There we go. Okay, let me make a note. I get x is greater than or equal to 3. Got that one? Let's do a number line. Visualize it. All right, so at 3, you got closed and to the right. Repeat. Come over here. We got an even root again. Which means the radicand has to stay greater than or equal to 0. Well, that radicand is just x. So you've just found the domain 4 times, which is why you can see that that Desmos link helping you with domain and range is really important. Okay? You should know we're only doing domain on this. We're not doing range. Thank goodness.
Bracket 3, parentheses, or bracket 3, infinity, parentheses, and bracket 0.
Close. So the way you get your final answer, y'all with me? I've not lost you yet, right? What we've done is the same thing we've always been doing. Now this is the new part. The way you get your final answer is you have to take into consideration the innermost function's domain, because that's the one that goes in first, right? So we need to know what's its domain, and then the entire function. So it's kind of a domino, I guess you could say, like when we were finding like g of 1, remember that? We took the inner one, whatever you got, went into it again to get the answer. Remember that? Same thing here. You take the inner function domain and you layer it with the entire function's domain, and you take the overlap. Here's the visual. I've run out of room. I can't write it underneath it. So I'm going to come over here and copy it again. If you've got room, come underneath here, down here, and write it, okay? If you have the room. If not, you can come over here and copy it. So if I'm trying to do the domain of f of g, I need the domain of g. What's the domain of g? We laid it on here. We said it's what? Negative infinity to positive infinity. So that was the whole thing, right? Right? And then what's the domain of f of g? We said the domain of f of g was what? 3 closed to infinity. You with me? Layer them with the overlap. What do they have in common? The only thing they have in common is that, right? That means those are the only things allowed to be plugged in. What is that? That would be 3 to infinity. Do you see it? Whatever's allowed to be plugged into G is also allowed to be plugged into f of g, and that's what your domain is. So my answer, here's my answer. I'm going to make note. Answer. I'm going to spell it right. Answer. It would be closed circle on 3 to infinity. That is the domain of f of g. Now that's only the first one, so if you don't get that, don't jump at me yet. Let me show you another one. Let's do the domain of g of f. Okay, so it's the domain of g of f. We already found it. We said it's what? Greater than or equal to 0. So 0 closed to the right. Right? The only other one you got to think about is the innermost, the input. In this case, it's f. So I'm just going to copy an f, and I'm going to copy what I said the domain for f was. I'm trying to show you the visuals. The domain for f was what? Greater than or equal to 0. So what ended up happening here? They're the exact same, which means that is the domain. So my answer is bracket on 0 to infinity. Now let me throw a what if, and oh, it's already down, so I can do this. I'll just change colors. I'm going to go to light purple. Let's say what if. What if the domain of g of f was 5 with an open circle for some reason, to infinity? Then the overlap, what do they have in common? It would be the most restricted, it'd be 5 with a parenthesis and to infinity. Do you see that? It's what they have in common. The common shaded regions are what is allowed. Now let's do another what if. Let's say what if, this is a big what if, I'll go to orange so it stands out more. Let's say what if this one, if f, was the whole number line except for a big open circle on 0. It's a fraction with an x in the bottom. And then let's say g of f was this. So let me help you with the visual. What if that was what we were dealing with? So what's the overlap? Well, they definitely both go to infinity, but this one you cannot plug 0 in, right? So it would be parentheses 0 to infinity. None of this over here matters because it's not shaded up here. You see that? If you draw the number lines, it really, and if you stack them, and try to stack them where the numbers line up. You don't want 0 way over here and then 0 over here because then you can't see the overlap. Draw the number lines, it really helps. There is only one more slide of practice. Oh, it's Dinger. You never played Cranium? Board game? Oh, it's fun. So this is what I meant by we weren't going to finish 2-3 today. Look, we'll pick up on this on Monday. Okay. So your two homework is due Sunday night. By the way, I wanted to look at number 10 on it because Brody asked about number 10, and it was something that I think several people might get tripped up on. Yeah, y'all look up here. This is going to happen in number 10 in the 2-2 homework. Look, it's going to say, it's going to give you this graph, and it's going to say, what is the domain of G over F? And you're going to look at that graph and you're like, what in the world? Like, I don't even know what the functions are. It's trying to see, do you remember that if I give you a fraction, what about the bottom do you know? The denominator cannot be 0. So you've got to go to the graph and find where is F 0 on the x-axis, and that would be right here. You see that? Okay, so that number is off limits. So you would say to yourself, what is that? Well, in this case, it's 5. So 5 is off limits. Then to finish answering the question, you have to find, it's like we just practiced, you got to find that overlap. What do they have in common? They have 3 in common all the way up to 11. Skipping, which one? No, which one's it got to skip? It's got to skip 5, because 5 is where the blue graph, which in this case is the one in the bottom of the fraction, is 0. So the way you would write it is, it starts at 3 runs to 5, skip over 5, and ends on 11. That's going to happen in number 10 in the 2-2 homework. Okay? And it all depends on which one's in the bottom of the fraction. If G had been on bottom, there wouldn't have been an issue because G doesn't even cross the x-axis. You see that? So that's going to come up. Your 2-2 homework's due Sunday night. Your 2-3 homework will be due Tuesday night because we'll finish it Monday. Okay? There is a very good chance this test will not be next week. Which means there's a very good chance over the break at some point you will have to commit a few hours to studying so that you're not completely brain dead when you come back to me on that Monday, okay?